Hey guys, today we are talking about liquid-liquid extraction and bioseparations. So first of all, why should we care? As engineers, we are going to be designing these extractors and a career in future classes, and sometimes other individuals are not engineers who would like to use them. So we need to consider some factors. One of them is performance efficiency. How much money is being used to buy this extractor, and are they making enough profit to pay for it in the long run? Avoiding some surface active impurities, which is really important for the life of your extractor. Some surface active impurities can reduce the efficiency of your machine up to 60%. And then your production capacity. Do you need a lot of small extractions, or do you need like a really big one unit single extraction? For flexibility, again, this is so non-engineers can interact and manage with the extractor. In other words, can we design it to be accessible? We also have the ability to clean the extractor. If it's really hard, people are going to be less likely to buy your extractor if it's really hard to take apart and clean. And then again, easy operation falls under flexibility. And then this is our triangle phase diagram, which is used by us to either represent our mixture in mass, volume, or molecular percentage, where B is the solvent and C is the product. And this uses a lot of engineering skill sets. It is important to make this information and interface accessible to non-engineering individuals, so they do not need to sit down and do the calculations in order to use our product.
A quick refresh on liquid-liquid extraction is, here are the main processes happening. A feed stream containing media with product is fed into a vessel which contains a solvent. The solvent and media are mixed and then separated due to the difference in their densities. The solvent now contains portion of the desired product, whereas the solute is the concentrated product.
Some of the equations we have are the distribution coefficient and extraction factor, which can be used when solving single and multi-stage extraction problems. We also have the rejection ratio and percent of solute extracted, which can only be used for multi-unit processes. The distribution coefficient is the ratio of concentrations of solute in the light phase, YL, compared to that in the heavy phase, XH. The extraction factor is the ratio of the total mass of a solute in the extract to that in the other phase. The rejection ratio is the weight ratio of the solute, which is your product, leaving in the light phase compared to that leaving in the heavy phase. The percent of solute extracted is the amount of solute extracted through the number of stages that there are.
Alright, so there are many processes that use liquid-liquid extraction, and some examples of those are making perfume, diesel, or vegetable oil. So in the case of perfume, plants are put into like large rotating drums, and then the oils in those plants are dissolved in either petroleum ether or benzene. And then we take those oils and then we move it to another solvent, which is typically an alcohol. And then those oils dissolve in that alcohol, and then we can separate the oils from our undesired products with liquid-liquid extraction. And then on the bottom there we have kind of a large scale look at what that would look like, and then on the right there is a single unit liquid-liquid extraction chamber for perfumes. And then kind of a diagram version of this is on the left. We start with our plant matter, all of our solvents that reduce down to an oil, and then we'll dissolve that in an alcohol to remove any more undesired products through that liquid-liquid extraction on the left.
Here we will have a demonstration of a demo where we are mixing water and oil. The water and oil will separate due to the difference in densities, and you can see that here in our video. The water and oil begin to separate and a oil layer forms at the top of the mixture.
Alright, here are some references where we gathered our information from. And alright, thanks for watching, guys. Leave some questions for us in the comments. Hit that like button. Subscribe for more awesome content. And always, nerds, stay curious.